And welcome back, everyone. We have with us Daniel Oates-Lee, who's replacing Simon, who couldn't be here today. Same talk, same content, and yeah. Please take it away, Daniel.
Excellent. Hello, everybody. Thank you for attending today. What I'm going to be talking about today is an open source tool that we developed at Punk Security for hunting out weak network shares. This is both a blue defenders team tool and also a red teamers tool. And I'm going to explain what I mean by that as we're going through the talk today. Hopefully, I was hoping to do a live demo. It's not quite worked out the way I wanted it to, but I have got it pre-recorded, so we will get to still see the tool running. So what am I going to talk about today? So we're going to look at what the problem was that we were trying to address, how we approached it, and then how does SMBeagle work? What is it? And then we'll do a little demo, and I'll show you some of the features that we earmarked for future development. And we'd obviously also love people to feed back to us and tell us more tools and features that they would like in SMBeagle, so then we can enhance it, because this is an open source tool for the community to use. But first of all, who am I? So my name is Daniel Oates-Lee. I am a co-founder of Punk Security. Punk Security has only been running for about 12 months now, but I have worked in cybersecurity for the last 15, 16 years. I've been in IT for over 25 years. I started out as a developer, then moved into infrastructure, did a bit of networks, and then naturally fell into security because I could understand applications and networks and infrastructure and everything like that. So I'm currently a cybersecurity consultant specializing in DevSecOps. So DevSecOps is obviously that ability to be able to automate security tooling and automatically finding security defects in applications as you're testing them through a life cycle. I put down Terraformer because I am a very big fan of infrastructure as code. Everything that I build, everything that I try and do, I try and use Terraform or some form of infrastructure as code because I love automation. So I'm very passionate about that. I also do quite a bit of pen testing and hacking myself. I do quite a few capture the flags. So I have got some red skills, but I try and focus my skills more in like the blue, on the defenders side, and helping the development teams identify security defects. So what was the problem that we were trying to address? We decided that we found that during the pandemic, quite a lot of people that we was helping support, because we were at a previous consultancy, were getting hit with ransomware. And we thought, well, how can we help people get themselves ready for a ransomware issue? Because everybody's trying to stop ransomware from happening. But we believe that the best defense is actually knowing what you potentially will lose, as opposed to trying to stop something that is ever changing. So if you understand what your network is, where your files are, what is likely to be ransomware, you're going to be better prepared, which means that when you do get attacked and when you do get ransomware, you'll be in a much better position. There'll be less issues. So what were the main issues in our view for people not understanding their full network? Well, the first one is undocumented IT systems and technical debt. People building file shares or file servers, or undocumented infrastructure out there. There's IT staff regularly rotate through. We don't do a lot of documentation, and it's just chaos in some larger companies. We also don't tend to back up everything back up all our data. A lot of file shares out there in the world are either unknown or only known by a few people, and therefore they're not included inside backups. Network segmentation is another one. People in finance being able to access applications that shouldn't be accessed by the HR team, or the HR team accessing stuff that the finance team should only have access to, those kind of things. Poor security around web and mail protection. People going out and browsing straight out to the internet. the amount of companies out there where I've gone in and found that there's unrestricted egress and there's no web proxies, there's no filters, there's no nothing like that, is unreal. And mail protection itself, we're allowing a lot of ransomware to actually come in the form of phishing attacks and stuff like that. And that's an ever-changing thing. Users' permissions and awareness of what they've got access to. One of the big things that I find when I'm doing my pen tests or security audits is that a lot of like service desk guys have got domain admin rights, and it's on their standard account, and their standard account is incredibly weak. In my view, that's wrong. Or people that have moved from like customer care to HR, they retain their customer care permissions to a load of file shares that they shouldn't now really have access to anymore. So it's people aren't really doing that recertification process and checking their users every 12 months. Are you supposed to still have access to this? Are you still supposed, can we remove you, or can we give you a better set of permissions? And then endpoint configurations. And it's not just about security, have you got antivirus and what have you running? It's also, is the user running as local admin? Have you got services running that you shouldn't have running? Have you looked at the CIS security standards? So these are the kind of things that we'd listed out as the main reasons for people being hit by ransomware. So what was our approach? Well, we had a look at the list and we kind of went, right, well, undocumented and IT's technical debt systems, we could probably do something about that. We could probably script something to help search and fix that. Data backups, again, we can probably do something about that as well. If we've identified that there are network file shares that you didn't know about, then we can get that added in. We decided that network segmentation and email protection and web protection are done to death. There is no point in us trying to develop a tool that will help you be able to fix those, because there are lots of really good tools out there, and it's not difficult to be able to get that right. Well, it shouldn't be. User permissions and awareness. Again, we thought if we built a tool that helped you find your network shares, we could document out what those network shares were, inform the IT teams, get people to understand that maybe you need to be doing recertifications and stuff like that. And poor server configurations. This is we thought, well, yeah, again, we can look at NTFS shares, we can look at SMB shares, we can tell you that using the everyone group is a bad idea. You should be using authenticated users if you're in an Active Directory domain, those kind of little things like that. So that's where SMBeagle came from. It was to build this ransomware readiness audit tool, which will scan your network and identify any Samba shares that are out there on the network and are available for users to access. And we thought, well, it'd be a good idea to collect that information, pull it all together, and then publish it somewhere, so then network admins can view it and see what's going on. So how does SMBeagle work? It works in 5 stages, and I'm going to walk through all these stages because, again, the code is completely open source. It's out there on GitHub. If you think of something that could be done slightly better, feel free to pitch in. So the first stage is, in this instance, we're going to look at a client that's on a VPN, because you don't necessarily need to be on the main network. This was just to show that we are working remotely. A lot of people work remotely now and still need to access SMB shares, so they tend to access them over a VPN, but you could also be one of these client users inside the internal networks. So the first stage is SMBeagle can be passed. We don't like the word whitelist and blacklist anymore. That should have been changed. It should have been allow and deny lists. Sorry about that. But basically, you can feed in the inclusion networks and the networks that you want to exclude. SMBeagle will then also have a look at your current network stacks, so your network connection, so where your email servers are, what domain controller you're authenticated to, are you connected to any application servers that you're using, and it will grab those IP addresses. It will look at your local interfaces as well. So it will scan any networks that you're locally connected to. And then what it will then do is it will correlate a long list of all of these subnets and all of these networks that it wants to use. By default, if it identifies like a domain controller, we will take the last octet off, change it to a 0, and then do /24, which is that's generically, that's what people tend to do. You tend to use /24 networks quite often, which is why we added the allow and the deny lists, because there might be some networks that you might not want to scan for SMB shares. What SMBeagle will then do is it will test connectivity to those networks. So it will basically do an Nmap scan, but using the native Windows built-in connection, and it will build up that long list of those 24 addresses per subnet, sorry, 254 addresses per subnet, and it will iterate through every single IP address, looking to see if anything's responding to TCP port 445, which is Microsoft DS or network shares. And it will scan through, and any IP address that responds to that TCP port will get put into a special list, which then gets used in the next stage. So the next stage is, once we've identified those servers that have responded to 445, we will now go and check those servers. We will go and connect to them, and we will see what open shares they've got, what potential hidden shares they've got open, and we will then generate a list of all of the shares that then need to be scanned. What it will then do in stage 4 is it will connect to every single UNC share that it's identified. It will go through as a low privileged user. I think I forgot to say that this only runs as a low privileged user on a laptop. You don't need any privileges for any of this. And in fact, it works better if you don't run it with any privileged accounts. And what will happen is it will connect as that user, and it will see what that user can see. What files and folders are inside that share? Can they read, write, or delete in that share? It will collect information like creation, last updated, file extension, and it gathers all this information about your network shares. The last stage is it will then output that information directly into Elastic, so then we can dashboard it up and can show you it, or it can be dumped into a CSV file. Now, the beauty of doing it into Elastic is you can run this as multiple users from multiple devices, and then you will get a much larger visibility of what your network looks like and what permissions people have got and what file shares people can see. So that was the whole idea behind that. I think I'm still running just about on time. So let's have a little look at a demo. So this is a very basic standard network. We have a client here. It's just a Windows 10 client, and we've got a couple of servers. So we've got a couple of domain controllers. We've got a couple of file servers, and we've got a couple of other SMB shares that shouldn't really be open for anybody to use. So fingers crossed. Let's see whether this little video will work. And what I'm going to do is I'm going to walk you through the video. I'm just going to mute that. So what we've done is we've logged into a Windows 10 box as a low privileged user. What we're going to do is we're just going to have a quick look, and we're going to see that we've got a departmental network share, as you would normally expect. We can see that we've got a couple of different departments in there. We've got customer care, facilities, that kind of thing. And we're also doing roaming profiles. So the user's profile is being stored on a network share. So we're going to open up the command prompt, and we're just going to have a quick look and just show you that there are no hidden shares running in the background. I'm not doing any smoke and magic. I haven't pre-connected to any network share that we discover during this during this scan. And we're also just going to have a quick look and have a look at the network connections we've got. So we can see here that we've got connections to a lot of SMB shares. We've got some connections to various different IP addresses, including domain controllers. So what we're going to do now is, hopefully, I'm now going to go into use SMBeagle. Now, because we're all hackers, everybody loves a good command line tool. So what we've done is we've built SMBeagle to be a command line tool. It has now been digitally signed as well. So if you download SMBeagle from the internet and try and run it, it will not come up with any certificate warnings with Windows Defender. We've spent a little bit of our own money at Punk Security, and we've gone and bought a code signing certificate to make sure that everything's all clean when you're running these things. Because if you can't trust a security tool to be secure, then you shouldn't really be running it. So inside here, we've got various different switches. Where we've got the first switch here, which is -C. That allows you to specify the CSV file that you want to output to. We've got -E, which allows you to specify the IP address of your Elastic host. By default, we've hard coded it in to run on TCP port 2, the default port, which is 9200. We are looking to adjust that, so then you can specify your own. There are some other switches inside here, like the -F switch, which will allow you to, if you've got a very large network, it will take the first file inside the folder and it will document out those rather than doing every single file inside that folder, it will check to see if the user can rewrite and delete to that file and then move on to the next folder. So therefore you can speed it up, because if you've got thousands of files and thousands of directories and thousands of network shares, this is going to take forever. So the easiest thing to do for us is to allow you to be able to just document the first one and make an assumption that the rest of the files inside that folder have got the same permission set. We've also got some other areas here, like the exclusions networks. So remember I was telling you about the exclusions, excluded networks, and also the include networks as well. We've got those options inside there as well for you. You can run this quietly if you wanted to, so you don't see the output, but by default it will give you a nice little bit of information as we're running it. So just skip ahead a little bit. Right, so what we're going to do now is we're going to run SMBeagle. We're going to output to an Elastic service, and we're going to exclude our local area. So if I just pause this for a second, the first thing that you're going to see is it's found 4 networks that it's currently connected to. So we can see here we've got a 172.16.10.0/24 network, 172.16.100.0/24 network, a 0 network, and then IPv6. It doesn't currently work across IPv6. That's something that we're looking at fixing later on. We're then going to exclude the IPv6 network, and it's going to tell you the networks that it's going to be able to scan against. Now, what it's been able to identify here is it's identified 5 different IP addresses that it can currently connect to, and so it can go and scan. It's then, remember, that's stage 2. Stage 3 is here. So you can see here that we've got all of the UNC network shares that we can connect to. So we saw previously that we could see the departmental UNC share. We can also see the user profile share, which we're connected to. But hang on about, there's a software share here. We weren't mapped to that previously, and we weren't mapped to any of these net and syslog false shares either. So they're all newly discovered as well. So if I just leave that to continue running, what it's going to do now in stage 4 is it's going to connect to every single one of these network shares, and it's going to go and download. It's going to go and connect, and it's going to go and extract all of the files, the folders, and the permissions that user has to those files and folders. So if we just skip along. So what we're going to do now is I'm going to rerun this, but I'm going to output it to a CSV file. So then we can see what's inside the CSV file, because I'm going to show you the Elastic, the Kibana dashboards that we've built for people as is like a bare basics kind of, this is how you can get in there and you can have a look at stuff. So if we just skip ahead a little bit, and here is the CSV file. So it's just a text delimited CSV file, and the kind of things that you're going to get is you're going to get the file name at the beginning, then you're going to get the file extension, then you're going to get the username that identified, that found that file, the workstation that it was found from, the full UNC path, the creation time, the last write time as well, which is collected from the NTFS data, and was the user able to read, write, or delete that file, and the directory type, which will be SMB, and then the base direct, like the full UNC path, so you can get to it later on later on. Now, one of the things that we've also identified is that red teamers have started to use SMBeagle during pen tests for this exact reason. They've identified that they can go and hunt down software shares, because which admin would ever hard code a password inside a configuration or a deployment script? That would never happen, would it? So red teamers are beginning to love this, and pen testers are as well. I'll come on to that a little bit later on. So that is the end of the demo. So what does the Kibana dashboard looks like? So this, oh, sorry, that's my voice. I thought somebody was talking over me then. So inside Elastic, what we do is we get SMBeagle to write out a brand new index every single time this runs. So it'll write it out with the current date, and it will dump the data into there for you. So you can now do a historical next series of scans as well. So not only can you do it for multiple users, multiple devices, but you can also get this to run over multiple days and see a period of time. How are new network shares being discovered, or are new vulnerabilities being introduced, and how do we need to address this? This is just going over the Kibana pattern. Inside here, this is just basically showing you all of that good data that we got inside the CSV file. It's now visualized, and it's a little neater and easier to read inside Elastic. So we can still got exactly the same information. You can see that the user profile areas and the information that we saw inside the CSV file. This is the Kibana dashboard. So it will easily just show you how many unique directories you've got across your network, where your file shares are, how many unique file names have you got, what are your file extensions. That comes in quite handy for the pen testers, because now they can drill down and just go for the PS1s or the ini files or the batch files, and they can drill straight down and find out exactly where those files are, so they can go and evaluate them. So in this instance, we've drilled down into the software share. So we can see that there's 6 unique file extensions. We can see PS1s, we can see PI files, we can see some text files. And as we come down, we can then see exactly where those script files are, so the pen testers can go and drill straight into that information. Inside if you were to remove all of the filters up at the top, you can then start seeing the unique paths, and you can see are those users able to read, write, and delete to those different directories and to those files. And that could be really useful information. So for a software share, why should a user be able to read, write, and delete to a software share, a standard user? Well, they shouldn't. Therefore, that's an identifies you. 5 minutes left. Thank you. So what I'm going to do is I'm going to move on quickly on to the to our future roadmap, because we believe that once we've started developing these tools, it's no good just developing a tool and then throwing it over the line and just going, yay, aren't we great? What we want to do is we want to take in more inputs. So these are some of the inputs that we've had over the last kind of 6 months of the life of SMBeagle. So people have asked us, can we introduce the ARP tables? Can you pull that information in during stage 1? Yeah, we absolutely can. We can also look at DNS cache, and we are looking at those at the moment. One of the requests by the pen testing community and the red teamers was to port this onto Kali Linux. We have done that now, and it is being launched into the Kali repo in the next few weeks. We will be hopefully launching that in the next few weeks. So there is a pen tester's version of this, and then you can just, rather than looking at your local network connections, you can only specify on the Kali tool exactly what networks you want to scan. But again, it's a really great tool. We're also looking at how we can look at legacy file shares as well. So ones that run on NetBIOS, and other older networks technologies, because there are a lot of older network shares out there, like the CIF shares and stuff like that. We're also looking at how we can integrate this into cloud technologies. So we have designed something that will work now with OneDrive and SharePoint. So you can scan your OneDrive and your SharePoint environments, and you can identify what file permissions are up there, but it's not ready yet for a general release. We've also been asked, can we put a regex text scanner in there as well? So when the pen testers are running their tools, they can look for the word password or look for a particular phrase inside the text files if you want to scan against like a TXT file or a PS1 file or a PI file. We'd also like to detail out more about the access control lists. So can we pull out the NTFS ACLs and dump those out, so then people can build up a much richer version of what their network shares look like. And the last one is we would like to give you command line stats as well. So when you finish running the CLI tool, you then get a nice little summary of what this looks like. How many files have we scanned? How many readable, writable directories have we identified? And as I say, this is completely open source. So please feel free to go to GitHub, go download the pre-compiled executable, play with it, tell us if you've got any problems with it. Feedback is key to us, because if we don't get feedback, we can't enhance more features about this. So I'll open the floor to any questions.
Awesome. So I'm just going to very quickly go to the questions and answers section. Right. So one of the first questions we've had is that this is a great tool. That's more of a statement. How do you identify if the shares the tool discovers are real or honeypots? Can you make the distinction?
Not currently, no. So what we're doing is we're just documenting the SMB shares, and then we just put that information out into Elastic, and then it'll allow you to identify. You can then do a bit of investigation. The operations team should know where their honeypot ones are, so they could exclude that host from the network scan. If it's a red teamer or a pen tester that's running this, they won't know that until they go and have a look at that network share. So hopefully that answers the question.
It does. Thank you so much. We also have another question, which would be, would you be able to drop the link in the chat? Some people weren't able to screenshot it in time, so I know that would be greatly appreciated if it were in the Twitch.
Yep, by all means, I can do that now. I am not.
I've done it.
Oh, you've already done it. Thank you.
Perfect.
I'm not the greatest. I'm not the greatest with Zoom at the moment, so I'm getting myself on Twitch. I'm getting myself brought up to speed.
Hey, no worries. You're doing fantastic. And I believe we have one more question, Nikos.
We do not. It was the link.
Oh, it was just the link. Oh, excellent. Yeah. So we do have some. So I'm going to put a little plug in here. If you head across to punksecurity.co.uk, you'll find that we also have another great open source tool, which allows you to build web server logs. And that might not sound very interesting, but it hides an attack inside the web server log for you to go and try and find. So it's almost like a little threat hunting CTF automated challenge. And every time you run pwn spoof, which is the name of the Python script, it will generate you a brand new set of web logs. So if you think SMBeagle's good, go check out pwn spoof.
We've actually been using them for the CTF. That's next week.
Yeah, I know. It is a great tool. We have got another talk about that, but I delivered that B-sides in Dublin just the other week. So I thought we thought we'd do SMBeagle this time, because it's another great tool that we've built. And we have got some other tools that are coming along the line that we'll be making open source as well. But yeah, this one hasn't had a lot of traction or a lot of visibility at the moment.
Yeah, thanks a lot, Daniel, for subbing in for Simon. I hope everything's going to be all right with him. And yeah, thanks for your time.
No problem.
It was
Thank you very much, guys.